The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. Thank you so much for tuning in to another episode of our Best Practices webinar series with SevenSignal. If you'd like to, please let us know where you are logging in from today to join us. I am currently in the Cleveland headquarters office. We are also joined today by Mike Graham. And Mike, I believe you're tuning in from North Carolina. Is that correct?
That's right.
Awesome. And we also have the return of Jim Vada joining us from Cincinnati. Thank you, Jim, for being here again.
You can't get rid of me. I'm
I
still
can't
here.
get rid of you. No, the constant reminder that you're still in Cincinnati, but glad to have you back and glad to have you back, Mike, as well. I see a couple of you dropping in the question panel where you're joining us from. We have Chris joining us from the UK. Welcome back. We have Forrest joining us from Lansing. Thank you for tuning in today. We also have Dan joining us again from Stockholm, Sweden. And I see a couple more people tuning in here. Please let us know if you're joining us from home, if you're in the office, and we will check back in with you later at the end of the webinar. So we will go ahead and get started here. So we are SevenSignal, the leader in wireless experience monitoring, and we'll go a little bit more into depth as to what that means for us and what our mission is as SevenSignal. So today we've got a really great topic, a very popular topic, 10 huge Wi-Fi antenna mistakes that you need to avoid. And as I said, we are joined by Mike Graham today, who will be going through this topic with us with Jim Vada. And I am Kelsey Rizzuto, the marketing specialist here for the SevenSignal team. Really excited to dive into this and get started. So thank you both for being here. All right, we'll start it off with a few announcements. If you've joined us in the past, these will look pretty familiar. But just to begin, we do partner with CWNP for every single one of our webinars. So if you're pursuing a certification and you're watching these weekly webinars, you are eligible for CE credits. So if you're interested in that, just shoot us a message or an email, and we can get a certificate sent over to you shortly. We also put on a product tour every single Friday at 12 noon Eastern at go.sevensignal.com/tour. And we'll go ahead and drop that link in the chat here in case you are interested in registering. We don't really get too deep into the products or any kind of demo on these weekly Wednesday webinars. The purpose for these webinars are really just to dive into some really popular topics, connect with our Wi-Fi community, and learn and grow together. So we also have some pretty exciting updates in regard to our product. Just to start off, we announced just last week our release of Mobileye for iGel Linux. We also last month recently added enhancements to Sapphire Eye over-the-air mode. And last month as well, we announced the release of a portable Sapphire Eye sensor. So a lot of really exciting updates here. If you haven't gone and registered for a product tour recently, suggest doing so just so you can keep up with what's going on here. Moving forward, we do post all of our webinar recordings on YouTube after the broadcast. So you can look us up at SevenSignal and watch some of our archived webinars, and stay tuned for today's webinar that will be posted there shortly this afternoon. We are also very active on Twitter, so go ahead and give us a follow at SevenSignal. And this afternoon, we will be posting the slides from today's presentation as well. If you're interested in the slides and you aren't active on Twitter, that's no problem. Just shoot us a message and we can send those over to you via email. We also really look at our Twitter followers because recently we've been giving away a lot of SevenSignal merchandise. So I'm going to go ahead and read last week's winners who either followed us on Twitter, engaged with our trivia questions, and will be some lucky winners receiving some swag soon. So last week we had Urtaza Ahmad, Kurt Neiman, and Jason Hanks. So congratulations to you three. As I said last week, we recently received SevenSignal branded masks, which you will be receiving shortly. And Jim, I said we needed to send you some. And Mike, I believe you don't have these yet either. So we'll have to get you a couple of these.
They existed.
Yes, they're going fast even around the office, so a hot commodity over here. So we'll get those to you sent soon. And for the rest of you, engage with today's trivia question, follow us on Twitter, and you may as well receive them asked soon as well too. All right, so moving on, another exciting announcement here that we are really proud of. We have recently been recognized in the Gartner 2020 Market Guide for Digital Experience Monitoring. Gartner has recognized SevenSignal as a representative vendor for Mobileye. And we'll go ahead and drop a link in the chat here if you care to go ahead and check out that report. All right, moving forward, just to give you a little background and history on SevenSignal, we were established in 2007 in Helsinki, Finland, and we've hit a lot of major milestones across the way that we're really proud of. We're proud of the 1 billion data points that we're analyzing daily, in addition to the 5 million devices monitored daily as well. We have over 200 customers, over 30 partners, and 14 patents, constantly innovating and evolving in an ever-changing industry, which goes to show that the technology you see from SevenSignal, you are only going to see from SevenSignal. We are also certified in over 40 countries, and we are GDPR compliant for our EU folks on the line, which essentially means that we take data and privacy very, very seriously for all of our users across the globe. All right, as I mentioned before, with SevenSignal, our mission is with wireless experience monitoring. And what we do is basically to enhance that digital experience, because we believe that the digital experience matters, and it's largely connected to Wi-Fi and connectivity. So what we're able to provide is full visibility into the end user experience through an outside-in approach with our platform of Mobileye and Sapphire, which is also completely AP and device agnostic, which complements those great tools, great technologies that you already have installed on the network. So as I said, the digital experience matters, and when it's negatively affected, it usually bubbles up to one of these top 7 Wi-Fi problems here, such as congestion, coverage loss, co-channel and radio interference, roaming issues, and more. And how we're able to detect those problems is by running active and passive tests on the edge of the network, looking for things like throughput, packet loss, latency and jitter, adapter and driver issues, and more. So to give you a little bit more insight as to what is so different about this, if you look at your typical enterprise LAN infrastructure, you've already got those great tools, great technologies, as I mentioned before, installed on the network, such as your Riverbed, Cisco, Aruba, Appneta, and more. But what SevenSignal can do is take that one step further, picking up where they leave off by providing Mobileye, giving you full visibility into the end user experience. With Mobileye, it can be installed on essentially any mobile device, from your laptops, your mobile phones, your workstation on wheels, your Zebra and Spectralink scanners, and more. And Mobileye can be installed on any macOS, Linux, Android, and Windows device. We also have Sapphire, which are the sensors installed up in the rafters looking down on the network, which are giving you that service level quality and RF visibility as well. But what we can do to take it one step further is give you that external network visibility. A lot of those great tools and technologies on your enterprise LAN infrastructure, you're not really using, as most of us are working from home in the midst of all these changes here. So with Mobileye, we can give you visibility into that end user experience from your multi-tenant apartment, your home, if you're working in a coffee shop, giving you that full visibility, full reliability as to what is occurring in your personal home network. And as I said, a lot of us here on the line are working from home, and a lot of us will continue to do so. For me, I'm in the office a couple of days a week and a couple of days at home, and 72% of office workers want to continue that kind of trend moving forward. So we do need that kind of reliability and visibility into those home networks as well for the foreseeable future. So to connect with this, we've been doing a give back. Mobileye offer 50 devices for 50 days, and we'll go ahead and drop that link in the chat here if you care to check it out and see what it's all about. All right, on with the show here. We do have a trivia question today that Mike Graham provided us. As I said before, we do offer swag and merchandise for this, so care to engage with this. I'm going to go ahead and launch this poll here. Can you guys see this question here?
Yep.
Awesome. So of the following antenna connector types, which one is the smallest? And I see
Mike, you didn't go easy on him this time.
No, I didn't. You know, today is, while people are answering, today is the 954th anniversary of the Battle of Hastings, and I was thinking about doing a question on that, but decided to stick with the RF.
Yep. Good idea.
All right, I see a few of you answering now. I'm going to go ahead and close this poll, and let's see, how did we do here, Mike?
We did really well, although, you know, kind of more ends than I expected there. That's a big old connector.
Awesome. All right, so I'm going to go ahead and hide this poll here. And we're going to go ahead and pass the controls over to Mike, who is going to dive into this antenna topic today. Go ahead and take it away, Mike.
All right, let's see if I can make this. Oh no, I closed my presentation. All right, can everybody see my screen?
Looks good.
Yes.
Great. Start with just a few words about myself. I have been designing, installing, and troubleshooting wireless networks since 1994, the winter of 94, 95. I sat down this morning and figured that out, which, yes, is about 5 years before 802.11b. So I got started at 450 megahertz and 900 megahertz and have been around for the whole progression since then. I've been with SevenSignal for almost 7 years. It'll be 7 years this fall. Have spent my whole professional life doing wireless of some sort or another with a little tour through the surveillance world after 9/11, whenever that was so rich. But kind of a wireless guy from way back. Moving on. This topic, the 10 antennas topic, actually is based on a posting that we've had on our website since very early, written by Veli-Pekka Katonen, our founder and the original artist of SevenSignal. And so I've just taken his presentation or his blog post and put a little bit of graphics around it and thought we would talk about that. I want to start with kind of 3 principles for using omnidirectional antennas, and that's mostly what we're talking about here. Is going to be omnidirectional antennas that are going to be typical of installations in offices and warehouses, and really by far the most used antenna. But those are, you know, first, omnidirectional antennas, they like open space. They don't want to be up against other objects. They like a little bit of elbow room, and so we want to put those in free space as much as we can. They are best, obviously, near the area of coverage that we need. So we want to put those antennas close to the users. And finally, we want to put the signal where the clients are. So even if we can't quite put the antennas there, we want to pick the antennas to put the signal where the clients are. And moving on here, we have, and sorry, I'm trying to drag some of this stuff out of my way. We have I've broken down sort of the issues into some causes and effects. And the first of those is that if we get within a few inches of other objects, especially dense or metallic objects, it's going to change the tuning of the antenna. So the antenna is tuned to radiate most efficiently at 2.4 gigahertz or 5 gigahertz. And as you place objects near the antenna, it's going to affect the resonant frequencies of the antenna and the frequencies at which they're most efficient. The other is that if you place the antenna close to other objects, it's going to sort of be part of the antenna, and it's going to change the way the antenna pattern is, the direction of focus for the antenna, that sort of thing. The third is wasted signal. If we put an omnidirectional antenna off to the side of a coverage area, then a large part of what that antenna is covering aren't going to have any client devices in it. It's going to waste half of the capacity of the access point. Next up, it's that we don't have coverage where the clients are. And usually that's going to be, we put the antenna way up in the ceiling and the clients are way down on the floor, those kind of issues. Also, we want to avoid placing antennas where the APs are going to hear each other better than they hear the client devices they're trying to communicate with. That's another issue and somewhat unavoidable, but an issue with putting antennas up in the ceiling. Frequently they'll have very clear lines of sight between the access points, but the clients are down at ground level and they're obstructed by cubicle walls or pallet racking in a warehouse or all of that stuff that lives near the floor. And then finally, we want to be really aware of obstructions between the users and the antennas. So, we want that clear line of sight as much as we can get it. And the first of these that we're going to cover is putting the access point up in the ceiling somewhere with all the pipes and ducts. And I don't actually see the access point in this picture, but I found it when I picked out this picture. And somewhere up in all of that mass of pipes, there is an access point. And whenever we get up there, amongst all that stuff, we're going to, first we're going to have the access point up close to big metal objects, so it's going to affect the tuning. It's going to affect the pattern of the antenna, and it's going to obstruct the path between the access point and the user. I'll bet you've seen a few of these, Jim.
I have, yep. And sometimes it's done as a matter of convenience because let's just, strap that AP up to one of those pipes instead of worrying about the T-bar. And sometimes it's done for aesthetic concerns.
Yep.
And like a lot of issues we'll talk about, someone will put the AP there, see that their Wi-Fi still works, and just walk away and say that's good enough. But
yeah,
we're not going to have anywhere near the, optimized performance that we could because of the RF issues these things introduce.
Yeah, we're really fortunate that Wi-Fi is pretty tolerant and it will work at some level even in some pretty tough situations. Moving on, and I don't know why it is. I see this in hospitals a lot where they don't bury it up in the pipes, but they'll lay it on top of a ceiling tile and poke the antennas through. This one you can even see one of the antennas has had a little bit of damage on the end of it, but not a good way to mount these either. And the primary issue with these is, you're right up against these metal T-bars. It's going to affect the tuning of the antenna. To some extent, it's probably going to affect the pattern as well. And it looks really dumb. So let's try not to do this either. Here's one, and this one is another one that's so easy to do. Is you mount the access point up against a wall, and that's bad in a couple of ways. You know, first there's, as we've talked about before, having an object right up against an antenna is going to affect the tuning of the antenna frequency. And the other one is it's trying to cover that area behind the wall, and that's probably not where your users are. So once again, you need to keep those omnidirectional antennas out in the middle of things. That's really where they're happiest. And we've got a couple of slides on these. And we can see here, not a hugely high roof, but still a tall roof, access point up there in the roof, clients down on the floor. So we're triggering or we're hitting that, you know, signal up at the ceiling level, not down where the clients are. We're wasting coverage. We're covering the ceiling really well, but maybe not the floor. And because there's a clear line of sight up there, the access points are going to hear each other really well. In a large facility, there's going to be a ton of co-channel interference. So not the best way to mount them. And then in the next slide, we have very much the same issue, just worse. Really high ceilings, warehouse ceilings, big collinear omnis, a lot of gain up there. And we actually are running a POC with a customer now that I believe this is the issue they're having. They have their access points up at about 30 feet, about 6 dBi of gain on the antenna. And what our Mobileye product, which is on their client devices down at floor level, are reporting back is consistently coverage problems and co-channel interference. So it hears a ton of access points, but it doesn't hear any of them very well. So, you know, bad news. And I know I've just told you you can't put the access points way up high in the ceiling, and that brings up the question of, you know, what do you do with the access points? And there's some solutions there. The one on the left, I really like. This actually is very aesthetic. It's easy to do for your electrician. And that's just hang the access point off of a long piece of conduit and drop those access points down closer to the clients. On the right, you see this one in warehouses a lot. Instead of trying to mount up over all of that high pallet racking, go along the sidewalls, take some wide-angle patch antennas and fire away down the aisles instead of trying to cover from above. I know, Jim, that you're a big fan of the one on the right.
Yeah, absolutely. Particularly in big open areas like a warehouse, where your if the RF isn't sort of constrained by a directional antenna, it's just going to go everywhere, and you're going to have a lot of contention and co-channel interference. And having it focused in a beam sort of focuses the energy, so you have a longer coverage pattern down the aisle, for instance, in the warehouse where that's pointing. So it gives you the best signal right where you need it, and the least amount of signal where you don't want it.
Yeah, that's you get kind of long, skinny coverage areas instead of round, blobby ones, and it can help devices roam as well, because it gives you some fairly sharp cutoffs whenever you move away from the access point and move out of the coverage area, and you move into the next one. There's a rapid decrease of signal on one, and that's more likely to trigger devices to roam. So either of these are much better than putting the access points way up in the ceiling. especially with high gain antennas. And we could do that when we were covering 30 or 40,000 square feet with an access point, and we needed a few kilobits, but that isn't the world we live in anymore. So we need to kind of knock off those older practices. And this one, very much like the antenna up against a wall, whenever you have your access point, your router off in a corner of a building, and you get great coverage on that side of the building, terrible coverage in the rest of the building. And this is something we've seen a lot here recently with all of the work from home. And we've started having more and more customers running Mobileye in home environments. And we sort of expected, I think, that when we started looking at those environments, we were going to see a ton of co-channel and adjacent channel interference from neighbors in apartment blocks and that sort of thing. And we do see some of that, but I think the worst issue that we're seeing in home work environments is coverage. And whenever we investigate a little bit more deeply, it's frequently this. The router is going to be off at one end of the house. The person's office is going to be at the other end of the house, and they're just going to have lousy coverage. So, once again, omnidirectional antennas, built-in integrated antennas and access points or routers, they're really happiest, they really work best in the middle of things. So if you can avoid putting them off in the corner of the building, you really should. See this one all the time. And I'm not really sure why. It's not that much easier to mount an access point to a wall than it is to a ceiling. But most of the access points with integrated antennas have got a little bit of gain off to the sides. So in this case, there's a little divot kind of under the antenna, and more gain out to the sides. Whenever you mount the antenna on a wall, you're basically pointing that null in the antenna, that hole in the bottom, right into the room where you're trying to get coverage. You're wasting coverage at the ceiling, at the floor. You're interfering with the access points on the floor above you and below you. You're probably creating some pretty weird reflections. And it's just as easy to put these access points on the ceiling. And in an office type environment with a 10 or 12 foot ceiling, that's exactly what those access points are designed for. So you need to be aware of the pattern on those integrated antenna access points particularly, and make sure that you use them appropriately, which usually means putting them on the ceiling. I don't see this one a lot. Sometimes with outdoor antennas, people are trying to disguise them. They will paint them. And that's okay as long as it's not a metallic containing paint. But this is another one of those where you're adding something that's reactive to electromagnetic fields, metal, and you're putting it close to the antenna, so it's going to affect the tuning of the antenna. It may affect the pattern as well. And really, without pretty sophisticated measuring and equipment, you're not going to know that you are detuning the antenna. It's just not going to work as well. And actually, I was kind of stunned when I found this picture. This is actually somebody that is got a client that they're selling in an industrial metal enclosure, and it really is a metal enclosure, and there really is not an external antenna on it. So yeah, this is going to detune the antenna a bit, but even worse, it's going to very much obstruct that signal, and you're going to get really poor coverage. So if you have to do this and you need a wash down capable client or something like that, you can definitely put the access point or the client device in that metal enclosure, but you want to bring the antenna outside and you can, either pull a rubber duck outside, or there's a lot of very low profile antennas that would mount on the outside of an enclosure like this.
Yeah, Mike, I've unfortunately had the experience of having to support clients in that state, and it's amazing how the problem starts as being an issue with the network and Wi-Fi and access points, and almost no one ever thinks about, well, how is the client radio? What's its state? And of course, being in a metal box doesn't get much worse for RF performance.
No, it really doesn't. If it's a tight metal box, it's hard to get signal in or out of there. I've even been in a situation where you walk into like a walk-in freezer in a warehouse. It's a double metal box. It's got a metal skin on the outside and a metal skin on the inside, and insulation between it. And you step in there and close the door, and nothing gets out. Yeah, I think the point here is you have to think about the client as well. It's not just on the access point. And we see that a lot and you see this a lot on online forums is, people aren't getting the performance they want, and they want, a faster router. And it's like, well, you've got a single stream 8 to 11N client there. There is just nothing you're going to do on the router side that's going to help. So you definitely have to pay attention to both ends of the link, both the antenna and the placement and the equipment itself. Might have wandered away from antennas a little bit there. And I think our 10th one is a little bit different. It's not so much an antenna placement issue, it's more of a site survey issue, and that is that you have to think about handheld devices. In this case, we're talking about VoIP phones, but it really could be just about any sort of small handheld device. Is that you're going to use the phone held up against your head. You're going to have your phone or your hand wrapping around it in a lot of cases, and you're just enclosing that phone in a lot of signal absorbing material there. And if you have surveyed with a better client, a client with an external antenna, then you're going to find that the VoIP phone is going to have poor coverage because you did not take into account the poorer antenna and the partially obstructed antenna in this case. I'm sure you've seen that as well, Jim.
Yeah, definitely. And this is a good point, when you consider clients too, because the client you're using certainly won't have the sensitivity of your site survey instrument when it comes to coverage. And, specifically about a phone, if I just turn my phone 90 degrees, I've affected the RSSI it's, receiving. And if my head is between the access point of my phone, now I've got attenuation from that. So it's good to, give some margin, some headroom in your designs to account for those sort of client side coverage or signal strength issues.
Yeah, absolutely. That's really important. And you have to remember as well that even if you set a site survey goal of say -65, even at that signal strength, which is usually considered pretty good, it's still not going to perform as well as 10 dB more, -55. So if you're surveying down to the limits, when you get a weaker client in there, you're going to fall deep into retransmit and low data rate territory. And I think we've left a pretty good bit of time for some Q&As. So maybe we can take a few questions.
Yeah, sounds good, Mike. And we've had a lot of good questions come in, and we do have some time if people want to keep submitting some more questions. Let's see, where should we start? Interesting question here about omnidirectional APs. So in the warehouse example, would it be better for an omnidirectional AP, assuming that's what you're using, to be mounted on the floor pointing up versus a very high ceiling pointing down? So I guess it's what's the best worst option?
I've actually played around a little bit with access points under a floor pointing up, and I've never had good luck with that kind of design at all. So I'm going to go absolutely no with under floor or on floor kind of things, and I think a lot of it is that there's just so much obstruction. The lower you go on a building, the more stuff there is probably why that doesn't work well. Above is better, and what you can do instead of using those omnidirectional antennas, and hopefully you're not blocked into it, is you can take a low gain, either a series of low gain patches or for MIMO a multiple element antenna, a directional, really low gain, and point that at the floor, and you kind of cast like a floodlight pointing down instead of an omni pointing out is a really good way. What do you think, Jim?
Yeah, I think that is a design that comes with a lot of compromises you have to take into account when you've got those in-floor access points. It can be done, but you have to be really sensitive to furniture placement and where people will be and where anything in the areas is going to be placed. So you need to be careful with your design and do a site survey once, assuming it's a new construction, which is usually when access points get placed in the floor happens. You really want to be careful and do a site survey once everything's installed and there, because every piece of furniture and anything on the floor is going to affect the signal strength and coverage. And it's probably going to need you to make, alterations to the design. If an AP is mounted up high, firing down, it's going to be able to not be as affected by furniture as much. So a lot of compromises involved there. Now there is a special case. I think some of our customers that have stadiums and arenas will put, I'm thinking of an NBA customer that has access points built into the flooring and also under seats, and that works, with a very careful design. But of course, they have very limited deployment options there. So again, you have to accept the compromises.
Yeah, I really like the under the seat deployment in big sporting arenas and big music venues and that sort of thing. I think of all the bad options, that's probably the least bad.
Yeah. Here's a good question from Javier, who says, how much horizontal separation is recommended to avoid intermodulation interference with cellular AWS bands in the 2.4 gigahertz when the 2.4 gigahertz band is enabled in the same space as a cellular DAS? So a lot to unpack there. I think the most important factor to check with your AP vendors if they even have filtering built into the radio to account for some of that interference. Some of the larger AP vendors do that, and we'll list that on data sheets. Certainly something to look for. I don't actually know where the AWS band is, but we know from testing we've done that cellular in the 2.1 gigahertz and 1.8 gigahertz bands can produce harmonics that land straight in the middle of the 2.4 gigahertz band and really cause issues. So like any other RF installation, if you can create more distance between your antennas, that's a good best practice. But having the filtering built into the AP is going to be crucial.
Yeah, and remember, RF drops off is the square of the distance, so even a little bit of distance helps a lot. I mean, I would say, don't even consider it less than a couple of feet, but even that feels really close.
Yeah, for sure. Particularly because those DAS radios can be fairly high power.
Yeah.
Okay, a lot of questions. I'll just kind of summarize a lot of them, but what's the approach to, handling that warehouse environment where the shelves sometimes are full and the shelves are sometimes empty and sometimes they're in between? Any thoughts on that, Mike?
Yeah, actually, I do, and I've never been a huge fan of most of the vendors' automatic power control in their access points. I think a lot of times it just doesn't work very well, but it is your best weapon against environments that change a lot. So make sure that you have whatever your vendor calls it, but the automated radio management is I think your best defense against that. If you have more than a tiny installation, you just can't go out there and do anything manual on it. It's just doesn't scale. So I don't know any other way to handle it other than to kind of reluctantly trust the radio management.
Yep. Maybe another warehouse question. I like this one because I noticed this too. This is from Leopold, who says, would you say that directional antennas, like in the warehouse scenario, should be mounted away a bit from the wall, like in the example pictures you showed?
I'm fine with mounting them flat up against a wall. The great thing about putting them on one of those mounts is you can get some aiming on them that you don't get when you put them straight up against the wall. But I've done them flat against the wall and they work fine. Really, they're designed, directional antennas, that is, they're designed to go flat up against things. They don't need that space that the Omni needs, but the mount does give you some pointing ability, which can be pretty handy, especially when you need a little bit of down tilt or something.
Yep. Yeah, and that I like those adjustable mounts too, because particularly with directional antennas, especially mounted at height, predictive modeling may not quite be accurate enough, so that you'll go and do that validation survey and see, oh, my coverage is like 10 degrees too far to the left, or it's tilted a little bit too far down. And since it's on an adjustable mount, you just go up there and move it around, and you're good to go. Yeah. Maybe one last question here from Kunal. I think this will be a quick one. Can I install a Wi-Fi AP with integrated antennas on a 30 to 40 meter tower?
I'd say that's, call it 100 feet.
Roughly, yeah.
I'm going to say if you want coverage at ground level, that's really not a very good idea. there are some omnidirectional antennas that have electrical down tilt. So instead of covering out to the sides, the signal sort of droops to cover ground level, which are designed, those are the antennas that are designed to use up high. But, both because the integrated antennas don't have much gain in the best case, and what gain they do have is not doing you any favors up at the top of the tower. I wouldn't do it with an integrated.
I would not either. I would maybe go 10 or 12 feet up on the tower and put the AP there if we're trying to get coverage on the ground.
Absolutely. Get up over the, if it's, it sounds like maybe it's a parking lot or application or something like that, then yeah, get up high enough that you're up above the tops of cars and RVs and that kind of thing. Like I said, assuming it is a parking lot, and really no higher.
Yeah, for sure. All right, Kelsey, I think we've hit time.
All right, awesome. Well, thank you, Mike and Jim, for answering some of those questions for our attendees and for going through this really interesting topic and presentation today. Thank you to all of you for tuning in and giving us 45 minutes of your workday to go through this. We really appreciate it. And we've also inserted the link in the chat for next week's webinar if you are interested in joining us again. So thank you to everyone and have a great rest of your day.
Thanks, everybody. Thanks, Mike.
Thanks, Jim. Goodbye, everybody. Bye, Kelsey.
Bye.
See you, Kelsey.